All right. So I'm going to be giving you your final homework assignment of the semester today. And for the attendance for today's class, I'm going to have you upload an in-class exercise that we're working through today. You'll just be uploading the M file. We'll be writing a script together. It's actually just the continuation of last class's example that I know some people made some pretty good progress on, but I'm not sure if anyone completed it all the way. So we're going to begin with that, and then for the new material in today's class, we're going to be talking about how to save data as external files, and also how to read in data rather than having it defined inside of a script. Okay, now I wanted to point out that you need to have access to MU Online today because, number one, you're going to have to upload the M file for attendance, and so that's this one, 420, here at the bottom of the list. But for the homework assignment that I'm going to be handing out today, I wanted to point out that there is also an external text file that you need for that. So homework 9, you'll be uploading it as per usual, but here is the GVW text file. We've seen this before for an in-class exercise. This is that transportation data related to how many overweight trucks there are. We're going to be using that in homework 9. All right. So first things first, let's take a look at that example file that we didn't quite finish last time in class. You may remember that what we're trying to go for is a plot, and it's a nice smooth plot because we've got a lot of data points that have been defined, and there's 3 different equations depending on what time we're between. And so there were a lot of different components. I wrote down on the board some hints of the different pieces that you should work into your script. Just to conserve on time, I wanted to show you the version of the script that I've got here, and it may not be exactly what you've been writing, and that's fine. A program doesn't have to be identical in appearance to another program in order to function the same or to function correctly. Well, let's talk through this, and then I'll give you some time to modify what you've been working on to make sure that it's functional, and then it'll execute and create the graph. All right, so CLC and clear both clears the screen and clears all the previous variables, so we all know what that does. Now linspace is creating a vector, and it's from 0 to 30, which is our time range, and then 100 points. And so we're going to be calling that our time vector. And then x is the position vector, and we're filling it in with zeros just so that there is a variable that inside of this for statement, it can start writing in the calculations inside of this empty matrix. All right, so the heart of what we were doing last time in class is talking about calculations that repeat and how we have to begin with a counter. The number of times that the calculations should repeat. And so assigning this k variable here, that is our index, the number of times that it's going to repeat. And so inside of a for statement, the syntax here is we're telling it that this for statement should execute 100 times from 1 to 100. And then embedded inside of the for statement is a series of if-else statements. And there's 3 components there. And so the syntax is first an if statement, then else if, which means we're not done yet. Do this if the if didn't trigger, then do else if, as long as it meets the conditions. And then if neither of those 2 have happened, then the last thing that will by default occur is the else. And then the other component I wanted to point out is the AND statement here. And both of the situations have to be true inside of that AND statement. So the time has to be greater than or equal to 0, but less than 10. And you'll remember that t with k in parentheses there means that we're not doing it for the entire matrix T, because T is a big set of data. But what we're saying is do it for the kth element of that vector. And so when k is 1, it's going to do it for the first element in the vector. When k is 2, it's going to do it for the second element of the vector, and so on. So that gives you an idea of the structure here of the part of the program on the left side of the screen. The right side is just about the plot. And so I won't talk too much about that. That's just the repeated stuff that we've seen before. So the new information is here on the left. So let me pause the recording, give you a few minutes to get this in, modify if necessary what you'd been working on previously. And then this is the M file that you should save. And the reason why I'm really emphasizing that you should save this is having this as a reference will help you a lot on the homework assignment. And so I'd like you to have at least one functional M file that you can execute, that will generate a plot, that will show you the syntax you need to be using for the loop. Make my plot. All right, so the second part of the homework assignment, which deals with importing and saving and loading variables, you know, there are times when in the past what we've done is inside the script we've defined a variable. So for instance, we can have A defined inside of the script, and this will work fine as long as this is what we always want A to be. If we always want the matrix to have these numbers in it when we execute the script, then there's no problem. But as you might expect, it gives you more flexibility if you use the calculations as one component of the script, but the actual data itself is separate from the script. Because you may be generating data from lab experiments or downloading environmental data from online. You know, there's a huge range of places that the input data comes from, and it's not automatically going to be in your script. And you don't want to have to modify the program anytime you have new data. And so it's more convenient to kind of isolate those two things, the data in one bin and the processing of the data in another. So here in this example and what we've been doing so far, the vector was inside the script itself. But if we want to use different data sets, then the more efficient thing for us to do is to split those. And so, in other words, what we want to do is separate the creation and storage of data from the analysis of the data. So let's clear the command window and any variables that you've been using so far and put these numbers into the matrix A. These are the same numbers that we were working with last time in class, and the fact that you're having to type it in again kind of is a perfect illustration of how tedious it can be if you don't have the capacity to save variables, like we're going to learn how to do today. Now that you will learn how to save variables, this will be the last time that you need to type in this particular matrix. All right, so we've got the matrix defined. So what you need to do now is make sure that the directory is set to a location that you're going to be able to find, because what we're going to do is once we save that matrix, we want to investigate the size of the file that it creates and the format of the file that it creates, and we're going to do a few different things. And so browse either to your V drive, a folder on your V drive, or maybe if you've got a flash drive that you're saving all of your work onto, navigate to that. And now type in the command line, save A. And then we're going to go to that directory that you specified and see what it says. So I'm going to do ctemp. I'm going to have a new folder today that I'm going to call saving. Okay, so I'm going to browse here to ctemp and the saving subfolder. If you don't see the subfolder that you want it to be saving in, okay, so it doesn't want to be called saving. Let me rename that something different. I'll create a new folder. All right. Now, save A. And if you do that and then browse to the location that you'd specified using the File Explorer, you'll see here is A. What it's stored is any variables that we had defined. And so right now, we only had this variable A, and so we can clear it. So, by the way, double-click on the variable A, and you can see when it opens up this variable editor, it's all of the numbers that we'd typed in. And so we can clear it, and it goes away. So we'd have to normally type it in again, which is tedious, right? But since we'd saved that, instead of typing it again, we can open, and then you can see here in the folder ctemp today, whatever your subfolder is, it's probably named something different. Here's this variable A, and if you open it, then here is that matrix that we'd saved before. Now, we can have lots of them. I could type in a new matrix, and I could say B is 1, 2, 3, 5, 19, and so on. I could create a C. So the point is create a few variables, and then when you save it, now I'm going to call this one save variables. If I go and take a look at what it saved, now there's a folder called variables. And so I'm going to clear again. And so now all these variables are gone, and if I open, it's it's opening up all of the variables that I had created at the point of when I saved. So you can continue, you could define things as long as you want. We could have all sorts of numbers, and then when we save again, you'll notice from the timestamp here, this variable is 1127. That's the file that I created right now. So what you'll find when you save those, it's a .mat file. And that's a file extension that Matlab uses to save any sort of data that we want to assign as variables. Now it's really useful, especially when you're dealing with large data sets that you don't want to have to type in again, or that would be impractical to type in again. And as you might expect, there are lots of ways to create these .mat files. It can't only be limited to things that we type in ourselves, because sometimes you'll want to use MATLAB on data sets that have thousands of numbers. So was everyone able to create a .mat file? Any questions about that? All right, and so you can write a script that references those .mat files, and the command for doing that is you can use load. And so, for instance, we could have a script that will load A, and A will be an external file, but we have to be careful because A has to be in the same folder as the script that's executing. And so let's try doing that. Let's reference an externally saved set of variables. Okay, so here's this matrix A. If we want to see what's in it, it's that series of numbers that we typed in. And so now let's create a new script that follows this pattern. Okay, and now what can be confusing sometimes is when you say load A, that's the file name. You're not referencing an individual variable when you tell it to load A. And so I've got several different variable sets saved in my folder. I've got this variables one, and I've got A. And just to illustrate the fact that when we type in this, what comes after load is the variable file name and not an individual variable, I'm actually going to have it load variables rather than A. So load variables, which has all of these numbers. Okay, and then the rest of it. Now, this reference, length of A, is it saying within the variables that have been loaded, what's the reference of this one individual matrix A? And then it's going to create a matrix with however many variables we want it to have. Okay, so remember the whole point of this is just to it's a proof that Matlab can go and read an external data file, that the data itself doesn't have to be in the script. So let me save this script, and it has to be in the same folder as the variables file. All right, so let me make sure that both of those things are there. There's the example, which is a .m file, and then variables, which is .mat. And here, it's telling me, in the folder browser that's built into Matlab, I can see there as well that I've got this variables.mat file, which is these numbers, the example script, and then another data file that I don't have to reference all the data files that are in a folder. Okay, so I've saved that. I'm going to clear the screen, and then if you run it, all right, n is 13. Oh, do I need to suppress n? Yeah. So remember what this did from this is an example from a previous class. It was calculating x, and then if we open up x, we can see it was squaring each one of the terms in that matrix. Okay, so it did that without us having any data defined in the workspace beforehand. All right. So again, if I have none of the variables in the workspace, you can run, and what it's doing is it's reading the variables file in order to, in the end, calculate this matrix X. Okay, was everybody successful in getting it to read the external variable file? And you can save all sorts of things externally. You can save figures. In addition to the .mat file, you can have it save a plot and generate that as a JPEG file, for instance. And so you're using the save as command in order to do that. And let's give it a try with this example script. And so in this example script, you can see that we're defining a range of numbers from -5 to 5 in increments of 0.01. And then all we want to do is square each one of those. And remember that since we're squaring each term in here, we have to do the dot exponent operator. And then we're going to create a plot, but rather than having it plotted on the pop-up window that Matlab will generate, what we're going to do is we're going to assign the plot to the variable that's called FIG, which is an abbreviation for figure. It doesn't have to be that. There's nothing special here about FIG. We could have called it any variable name that we want, but the point is down here when we execute the save as command, then you're going to refer to whatever variable you named as equal to the plot that's created. So let's try that out. And again, we have to be kind of cognizant of the fact that it's going to save this parabola.jpg file in the same folder that the script itself is saved in. So I'll save the script. I'm going to call this the script itself make big. And then run it. And then if I browse over here, okay, there's the plot. And then let's see, here's the parabola file. So you'll notice the file extension here is a JPEG, and so that could be opened in any kind of program. You could paste that into a Word document. Looks like here in Windows it's opening it up in whatever the picture manager is that's specified as the default. But it has stored this external JPEG file. So again, the key elements here is that you, number one, need to assign the plot as a variable, and then you reference that variable, and the syntax there is within the save as. The first thing is the variable that you're calling, and then the second component after the comma is the external file name that you want it to save as. All right, so the next part of what we're going to do today is try to show you how you can start with some external text file and get that into a format that Matlab's able to read and process. So we've seen data like this before when we were working with Excel, and do you remember what all of these commas are in here for? Do you remember what the special term was that we used for tabs or commas or spaces? It's delimitation. And so when we were importing data to Excel, sometimes you had to specify whether it's tab delimited or comma delimited and so on. And so we'd like to have a similar process of importing it into Matlab. And Excel does a really great job of automatically recognizing how things are delimited, and usually you can just accept whatever defaults it's detected. And Matlab has some similar functionality, but it can sometimes need a little bit more interaction. So let's take a look at that. First of all, let's download the text file that's at the bottom, not of the homework folder, but just the main home page itself. Click on the home page. So at the bottom of the page here, strain gauge data. So what you'll need to do, I think, is right-click on it and save link as, because by default, most browsers will just display the text file rather than download it. So I'm going to create a new folder that I'm calling import, and then I'm going to put this strain gauge data in the import subfolder. And then if I open that, I can see it's just a bunch of data that I want to bring into Matlab. So I'll give everybody a moment to find and download that. Again, what you need to do, if you click on it, I think what it'll do by default is just display the data. And we don't want to display it in the browser. We want to save it. So go to the course content, right-click, and then save as. All right, so click on the Import Data button on the Home tab of Matlab. And I'm going to browse to the import and then identify the text file that we're going to bring in and click Open. All right, this is the pop-up that it gives us, and you'll notice that some of the cells are identified differently than others. You browse along and see what some of the cells are identified as unimportable. You can see the color highlighting is kind of showing a difference between some of these, and it may be that the naming of it is inconsistent with what Matlab can have as elements in an array. But what it'll give you is here in the unimportable cells, it'll give you the option of what it should write into the cells that can't be imported. You'll notice here that it's automatically detected that the data was comma delimited. But if we want to override that, just in similar way that we were importing data using Excel, you can identify what the actual delimiter character is. So the things I want you to be aware of is how you can change the delimitation, whether you can import this as a single one large matrix or if each column is a different vector, and then what to do with the cells that can't be imported. So let's not import everything, but let's just import one of the columns. The one that says B1874. All right, 1874. So this column, what we can do is change the width of it, and then see where it's saying strain, strain 1, strain 2, strain 3, strain 4. Let's change it to call it B1874. And then double check all the rest of the settings here to make sure it's as we like. So the range of data that's going to be coming in from G22 to G63, variable names row is 6. Okay, so I'm going to change this so that it's 22 through 63, because if we look through it, all of these other rows, row 1 through 21, that's just kind of like the preliminary metadata. The actual measurements themselves are only going from 22 through 66. And so I don't want to create a matrix that has a bunch of empty values and then maybe some words and so on. All right. So as the final step, we'll just click on Import Selection. And with any luck, then we'll have a new variable that we can look at over here, B1874. And if you double click on it, then here's 42 rows, 1 column, and it's the data that was in that text file. So we could do any calculations that we needed to in the ordinary way as if it was a variable that we'd created by typing the data into the command window. Okay, so did everybody get that column of data imported without any of the excess headers? Yeah, so let me demonstrate it one more time. All right, so I will close this import window. So all I've got right now is I've got the original stain. There, I forgot the R. So this is stain gauge data. I don't know if I've seen a stain gauge before, but anyway. All right, so what we're going to do is go to Import Data and browse to the import wherever you've got the file. All right, and it pops open this window, and it does its best to kind of identify what it should do with the data. You can see that it's identified some of these that can't be imported, and they're identified in yellow. But if I'm only interested in one of the columns here, then what I can do is find the one that I want. I think was it 1874. And so first of all, I'm going to rename that from strain 6. I'm going to call it, because that's what the variable name is going to be. And when I work with it in my script, maybe I've put together the script and it's expecting the matrix to be called B1874. Okay, so that's where you're naming what is going to be imported. And then the range, I'm going to have to make sure that it includes only where the numbers are themselves. And so I'm going to go from G22 down to G66. So I'm making sure that that's actually where the data ends. All right. And then all we have to do is click Import Selection. And it gives us this little note that it imported the variable. And we can verify that because now the variable is showing in the workspace. In this case, it looks like it didn't actually honor the fact that I only wanted to import where the numbers themselves were. So let me clear that and see what might have gone wrong. Oh, here. It didn't take that it was 22. Okay, so 22 through 66. All right. Make sure that it says that, import. I liked how it worked better the first time. All right, there it is. So now it's excluding all of those cells that weren't within the range of 22 through 66. All right, so now that that data is in the workspace, you can do with it whatever you like. You can create plots. You can include it into scripts. We could make a histogram. You remember histograms probably from when we were working in Excel. And so we could say in the command window histogram B1874 from 0 to 40 at a spacing of 2.5. That's defining the bins. And then it creates a histogram. And we could add axis labels and so on if we like to do that. All right. Well, that's all the new material that I have for you today. And in fact, when we have class on Tuesday, it's going to be time for you to spend working on the homework assignment for the most part. So you've got the homework assignment. I'd encourage you to get an early start on that. The best way to avoid it seeming like an overwhelming assignment is to come to class on Tuesday already armed with any questions. You know, like if you're going to have a stumbling block on this assignment, it's better for you to figure it out before we meet on Tuesday so that you can ask a question and get it resolved. Problem 1 is about the plotting of steel capacity, and then problem 2 is mostly loading and processing the data that refers to this homework assignments folder. At the bottom is the GVW file. All right, so that's it for today. I'll see you next Tuesday.